I want to just briefly talk about the first effort we've had to get everybody, or at least representatives of all the partners, together at the Johnnye River Sioux Tribe just a few weeks ago. And the Department of Cultural Preservation was kind enough to provide us with vehicles and 2 staff to actually accompany us through the whole thing. And the sampling that we did was based on some previous work that we had done to identify food sources that were growing in the floodplains that I mentioned, and how they were used and what we needed to be looking at, and looking at use of firewood, for example, use of sage and how it's used in the homes, and looking at some of the berries that are growing in the floodplains, and then also looking at the grasses and in the plants, trying to catch all the way down through the roots into the floodplain. I mentioned that the floodplains often went back as far as a half to 3/4 of a mile, and this is a riding arena that is probably about a half a mile back from the river. When EPA did composite samples in that arena, they came up with arsenic concentrations of 400 parts per million. They did not go back and try and parse any of that out to determine, that was 18 samples combined. So is that a reasonable average, equally distributed throughout, or do we have parts of that arena that are substantially higher? Are there isolated pockets that we might be able to clean? So the effort on this trip is to get a better sense of what is that distribution and how does it look with depth, and then go back and fill in those holes, and also look at placing air monitors to see what's really kicked up there. We were also able to see, it's a little hard to see here, but this is one giant cultivator with tines about this deep. So when they're ripping this arena, they're ripping fairly deeply. And that was really important for us to see in terms of interpretation of the data. We found 2 sort of extreme groups within the tribe. One that was very, very traditional, very heavy reliance on ceremonies that are conducted on an almost daily basis, if we count sweats into that story. And then we had another group that is much more traditional rancher community that doesn't participate very much in any of the ceremonial activities. And then, as might be expected, a large group in the middle that had somewhat intermediate exposures through both of those pathways. And so those are the kinds of questions that we're trying to answer with these sampling efforts. Chris alluded to this earlier. These are the results from the work that was done at Tachee Blue Gap that he described, with this 150-foot wall of waste, where we actually went in and we measured what was in the waste material. We looked at what's in the water that's percolating through that waste and getting into the livestock water troughs and the ponds that the livestock were drinking. And the results of the publication on this, showing the sensitivity of the movement of those chemicals to the pH, the calcium content, the iron content, and some of the other matrix that the contamination's occurring in, actually now have led to this site being prioritized for cleanup. And so those are the kinds of changes that we want to see happening as we move forward. And Chris had pointed to this, and this again flew in the face of the accepted belief at the time that we started this, where, all of the uranium that's sitting in those waste piles is pretty tightly bound, it's not going to be airborne, and we're not going to be really concerned about it. And what we've now been able to show is, no, it's actually, the toxic metals are way enriched as you get smaller and smaller and smaller fractions. This is only down to 63 microns, but we've now done even smaller size fractions. And as Chris mentioned, what we're concerned about with the small fractions is it goes much deeper into the lungs. So seeing these essentially nanoparticles of free uranium able to be mobilized in the dust, and then seeing the kind of dust storms that we get, give us incredible concern over what kinds of exposures might be occurring through inhalation. Those are the kinds of questions we'll be asking from the samples that we've started to collect. The work that we have been doing also on the Gold King mine spill, which Carletta talked about this morning. But as we started following the plume from the data that were being collected in the San Juan River, what we saw was the plume moving along, and then it disappeared, and then there was a rainstorm, and we started seeing spots develop. And we're looking here at iron. The blue is very low concentrations going up to very high concentrations in the red. So you start seeing these localized spots developing in relation to the rain. And when we look at all of it together, you see that these don't make a lot of sense in terms of a moving plume. We have about 25 families from the birth cohort who actually live in the chapters right along the river. So we have biomonitoring data on them from pre-spill, and have some sense of what these exposures might be. And then we have actually sent people up a couple of weeks after the spill up to the source area, and again looking at the geochemistry, what's going to make these sediments release the material that's found there, and what's going to make it mobile again. And what we're seeing now as we look longer term, arsenic and lead, you heard, are two of the main contaminants that we're worried about. If we look up at the origin in Cement Creek, and then this is now the Colorado portion of the Animas River, and now this is down into the New Mexico portion. And what you see are these spikes in arsenic that actually go above the MCL. And they're pretty well tied, but not perfectly tied. You can see this last one didn't spike, to the stream flow, which means as we get these rain events, we're seeing these things come out. And we see the same thing for lead, and our suspicion is we are not seeing something that's related to the Gold King mine spill. We're picking up contaminants that have been deposited because of all of the mine waste that's coming out of all of the drainages. So what we're in the process of doing now is looking at the rain patterns. What areas were actually impacted, and are they those canyons that we know have mill waste or mine waste stashed up and stored, and is it now being released from these sediments?